Welcome back. So, in this lecture, I'm going to talk about algorithms, what an algorithm is, and we're not going to dig too deep into algorithms because there are entire college courses on algorithms. The analysis of the algorithm, the design of the algorithm, the implementation of the algorithm. That's beyond the scope of what we're going to do here, but I want you to understand at the most basic level, sufficient enough to apply it to what we're doing, what an algorithm is. Now, before we get to the algorithm itself, let's retrace where we were when we were in the first module. In that first module, we talked about programming and why we program, how we program, and languages and whatnot. So, let's look at it from the standpoint that there is some solution that needs to be created. Now, some may say, as a programmer, that is our job title. That person is a programmer. I'd like to look at it as not just a programmer, but we are solution developers. Programmers are people that write code. What we're doing in this class is we're programming to develop solutions to, I don't want to say problems because they're not necessarily problems, they could be opportunities. Problem, that word has such a negative connotation to it. So let's say that we need to add two numbers together. That is what we need to do, the task that we need to perform. Add two numbers together. Okay? We need to break that task down into some kind of description. Now, many textbooks and many professors will use the analogy of an algorithm's like a recipe. And if we want to have the recipe for, let's say, making a grilled cheese sandwich, that recipe is much like the algorithm. What you need to do to perform that task, and it's laid out in a text format. That is in part, or in certain circumstances, that is correct on what an algorithm is. And depending on how you're looking at solution development or programming, that falls far short. Now, a lot of times the word algorithm is used in a mathematical context or a logical context. And in those examples, it would be more formula based, to where here's a mathematical or logical formula, and you need to take that formula and you need to write code to make it so, or to perform that task. And there's all kinds of mathematical symbols involved. We're not going to that level of creating an algorithm. We're not diving down to that narrow perspective. We're going to look at the recipe side of it and look at it from strictly the logic standpoint, and we can take these simple assignments that we're going to have to deal with and we'll break down into an algorithm. Now, in this course, we're going to be using Jupyter notebooks. And this is a Jupyter notebook being housed in Google Colab. Now, last time I edited this was quite some time ago. And it was when I first started redoing this class. And I've been working on redoing this course for a couple of years. This has been in the planning and development, laying it out. Now here we are finally at the end of 2022 implementing this revision of a course that It wasn't that it was broken and needed to be fixed. We needed to be more aligned with the current practices. And in a nutshell, I want to reduce the cost to you and make it a little easier. Things don't have to be complex and difficult. If you put the time into what we're doing, you get great results out of it. So, what is an algorithm? Now, in computer programming terms, an algorithm is a set of well-defined instructions to solve a particular problem. Now, as I said, it could be in mathematical formula format, or it could be in text format. And for what we're going to do, it's text formats. Now, the way I've got it worded here takes a set of inputs and produces a desired output. And, well, it may not necessarily be inputs, but let's just look at it as, in this example, we're going to take some input and produce some desired output. And I want an algorithm to add two numbers together. Well, the algorithm is 3 steps. Take 2 number inputs, add the numbers using the addition operator, display the result. That's a very basic algorithm. We could break it down into more steps or more detail, but that is the algorithm in a nutshell. Take those 2 inputs, use that mathematical operation, add them together, and then display the results. Now, how could we go beyond that? Well, we could have a little more detail, which would more narrowly define and be more specific about how we did those steps or tasks. And if we take that comparison that I talked about a little while ago, about it's like a recipe, make a grilled cheese sandwich. Well, here's the things you're going to need. Bread, cheese. Are you putting meat on it? You putting tomato on it? You need butter. You need how are you going to heat it up? What are you going to heat it up on? Do you need a plate? All the things you need to do it. And then the next step of it is, here is the step-by-step functionalities or the tasks you need to perform to actually do it. So the first section of it is the resources you need. You define them and you set them out in a step-by-step format. Here's a list of the things you need. And then beyond that, here's what you need to do. Now, if we write out the algorithm in that form, that will help us to lay out our code. Because when we think about the things we need to do what we're going to do, get prepared before you start doing the work. That's like the variables and the constants that I just talked about in the previous video. Get your constants, set those storage spaces, set them up. If you need to put something in them ahead of time, put them in them now. They'll be there ready when we go to do the work later. It may be something like, hey, we're going to need to use somebody else's code, so go ahead and import that code that somebody else created, or maybe some built-in libraries, and I'll talk more about that in subsequent videos. But there may be something that we're going to have to use. That's at the start of our algorithm. What follows is the step-by-step tasks. Some algorithms can be very long and complex. Some can be so straightforward and to the point. So, good algorithms, the things involved are defined precisely. Inputs and outputs. And when I say defined precisely, that goes back to the last lecture. What kind of input is coming in? Is it a string? Is it text? Is it a number? What kind of number? A whole number, an integer? Or is it a fractional number? Is it something that won't change, fixed? Or is it something that's dynamic and variable and can change over time? Each step in the algorithm should be clear and unambiguous, meaning it is very clear, there's no confusion about what is being done and how it's being done. We're talking about the grilled cheese sandwich. Yeah, no, you're not throwing that bread and cheese on an open fire without any grid in between it. There's a pan that you're going to have to use and how you do it. And the things that are taking place each step must happen in a specific sequence. That sequencing is important. You can't start grilling the grilled cheese sandwich before you've assembled it. Or can you? And that may be part of this special recipe of how it's done. An algorithm should not include the computer code itself. This is not coding. This is the logical structure of what's being done. It's quite different because if we're writing code in the algorithm, not all languages are the same. Not all computer languages are the same. So this is non-programming language specific. So we've got a couple of different algorithms here. And in the first one, step one, we're going to start what we're doing. Declare the variables num1, num2, and sum. Read the values in num1 and num2. From where? We don't know. It could be from a user, it could be from some other source. We will add those two variables together and take that value and assign it to sum. So that's assign. We talked about that in the last video. Here's the logic of it. num1 plus num2 is being assigned to sum. And then we display whatever's in sum, and it could be a specific format of displaying it. We could have that. And then once that's been done, our task ends. It started, step by step what we did, and stopped. The declare the variables, that was that separate section that I was talking about. And when we get into the coding aspect of it, we'll break it down into logical sections that align with what we're doing here. So we're sure that we have done each thing that is in the algorithm. Our computer program should align directly with what is being said in the algorithm, because the algorithm is what we're doing. That's the task we're performing. So here's another example. Find the largest number among three numbers. Let's go ahead and start. Declare three variables. We read the variables into this program, and we're going to have some conditional statements. If A is greater than B, well, let's say A is greater than B. What next? Let's check to see if A is greater than C. Well, if it is, say A is the largest number. Well, let's say it's not. We know A is bigger than B, and if A is not bigger than C, then that means that C is bigger than A, so that means C is the largest number. And then we see if B is greater than C. If it is, that means B is the largest number. If not, then C is the largest number. So there's the logic that would take place. And this is not, it may look like code. This is not code by any stretch. Okay? Because if, then, else, conditional statements that we're going to talk about I think it's chapter 4 or 5, module 4 or 5. Um, they're distinctly different from one language to the next. The syntax is quite different. Okay? And syntax is something that we've spoken about in that first module. The language is very specific in how things are said or presented within the code. So once this step-by-step logic has taken place, we're done. Because we took the inputs, processed them, and depending on how they were processed, there was a specific output that took place. And then we're done. Now, when we're assigned a task, when we have some solution that needs to be created, we break it down into steps, what resources need to be used, how are we going to do it, what outputs are created, and be specific in how it's supposed to look. That's not language specific. That is a specific output. In the class you may take after this one, programming in C#, the software that I currently use and the same software I used to use for COP1000 is very specific in how it evaluates the outputs. Programming case sensitivity is a deal breaker. Spelling matters. In C#, you have to have a semicolon at the end of each statement. Python is a very understanding language, or let me back up a second. When I say understanding, there's a version that we talked about in the first module that we're using, and we're using Python version 3.x. You could be using 3.2, 3.5, 3.7, whatever iteration, as long as it's in the 3 domain of Python. Now, the 3.x versions of Python are not as implicit as 2.x. In the 2.x versions, you could write code and the interpreter, compiler, would implicitly know what you wanted it to do. You weren't being as explicit as you are in 3.x. 3.x is considerably more explicit about things. And explicit does not necessarily mean X-rated. It just means the rules are far more strict. So the rules in 3.x are stricter than in 2.x. The rules in Python are more implicit, in my opinion, than in, let's say, Java or C#. There are things you have to do in those languages that you don't have to do them in Python. We're good. Python is a great language. It has a lot of libraries that have been built for it. There's a lot of people coding in it, so the functionality, the things that you can do with it, wow, it's immense what the capabilities are. So we're going to move on to pseudocode in the next lecture, and I'll see you there.